All right, welcome to another video. This is the after work video, and it's in the new topic for BGP, IPv6 and IPv4 peering communities. So I'm keeping a list of all the kind of underlying themes of this channel. The first one is concepts, not commands. The second one, I don't remember exactly what they all were. I think it was something like cautious curiosity or something like kind of always being curious, going the extra mile, reading the extra command, doing the extra show command, but doing so in a way that's not going to cause harm or kind of jump off a cliff. Oh, okay. Definitely one is look before you leap. All right, so let's kind of keep on task here and keep configuring this exercise. So it looks like I left off on the interface config, so it's time to configure BGP. Oops. And then this port here, which goes out to the other autonomous system, that's going to be passive. So I think it's, okay, I made it port 9. So I will set that to port 9. I might have, let's see what I did for, oops, and then set protocols, SIS until 0.0. But let's see what I did. So, oh, I did configure port 2 instead of port 9. Oh, yeah, it's not going to have anything for port 9, but port 2 will. There we go. Perfect. All right, so now it's time for the policy statements. Aha, so here's our community, EDU. So we're going to be, and this is, if you remember from the previous video, where I used a route filter. So this is an example of how you can configure, you can add routes to BGP. So we're going to export, send ISISN direct. Oh, never mind. Okay, so this is, never mind. This is a, we're using a route filter. But here's an example. Shoot. Well, I got a call. I hope that wasn't important. Anyways, continuing on. So protocol BGP, I think at 6 p.m. the call won't be super important. I hope not. So from community edu, set then metric 63, set then accept. Okay, and now up, edit, send ISIS, and direct term, oops. There we go. So yeah, all of these are examples on how you can redistribute protocol routes into BGP without using that route filter and then specifying the route with the exact. So you can kind of save yourself some configuration just by redistributing it from a protocol or using these or longer to include more than just the specific routes. That's something I always like to do, is keep things as simple and basic as possible to start. And then from there, get things more complex. All right, so I think my food order is at the door again. This kind of is a theme of Friday videos. Hopefully they'll just leave it there. Top edit policy options, community, oops, edu, set members. So let's look a little bit at this members. So community members, and then so I'm getting another call. Hi, this is Graham.
Hi, Graham. I just dropped.
Extra mile. So I'm going to bring it in. Hopefully he's not still at the door because we're all supposed to be socially distancing. But I'm just going to bring it in quick. All right, so yeah, it was pretty, I'm in Texas where it can get to be like pretty hot outside, so food delivery order just sitting at my door for a while. It's definitely not ideal, so it makes sense that he wanted me to go and get it right away, but you know, at the same time, man, I'm working. All right, so let's see here. Edit routing options, set router ID 192.0.3, set autonomous system 1. Control pipe display set relative. Okay, so hopefully this will all commit. Okay, so now moving on to device D. So here's that ISO net address, which is title, network entity title, I believe. It doesn't matter. I guess it kind of does matter. It matters. It definitely matters. It's going to matter for the test too, because I guarantee you there's going to be a situation where they give me either a duplicate one of these, or these aren't in the same area where they're meant to be, or they're in different areas where they were meant to be in the same areas, or they include an extra domain scope that makes things all wonky, or they don't have the correct level. That is all more than fair game for the exam. And I need to be prepared for that to be on there. That's the kind of thing that is more than fair to have on the exam. Oh, and I think I had my sharing paused. So okay, it's back up. We're sharing again. Everything is good. Hopefully, I can get an uninterrupted 45 minutes or so. And then I can take a walk and play some Quest and call it a day. But until then, I would like to work towards this exam because, yes, the world is going crazy right now, but if it happens to not be that crazy in September, when I plan to take the test, I would like to still take the test, if it is possible for me to do so. Even if it is not possible for me to do so, I would still like to take it. And even if I can't take the test, I'm hoping that just having this channel will give me similar benefits, just to show that I'm working towards it. All right, so we got one more router left. I believe I made this one 0, 0. I'm gonna double check though. I did. Okay, perfect. Okay, so we've got multiple addresses on this one, which is interesting. I think they're all going to get installed. Well, we'll see. We'll see. So let's see your set address. Just finish the configuration and look into what it's doing later. That's interesting that they're the same routes. I'm kind of not sure what they're getting at with this. All right, so everything is hopefully going to commit. Perfect. So let's take a look at the step-by-step, and if anything, here we go. So on device E, we configure the statics policy because it adds the edu community attribute to the statics. So let's look at that more closely. Show configuration policy options. Like display set. So it's going to, here we go. So from protocol static, then community add edu, then accept. And then we've got EBGP, static routes, router ID and AS number, classic regular stuff. Configure the edu to ISIS policy, which redistributes the edu tag BGP routes learned from device E and applies a metric of 63. Configure the send ISIS and direct policy, which redistributes devices to routes to device E through eBGP. Without this policy, device E would not have connectivity to the networks in AS1. All right, so we're ready to do the verification steps. So first verification is going to be on router D. show route protocol ISIS. Oh, and looks like we've already got an issue here. We're not getting any routes from ISIS, so let's see if the neighborship is up for ISIS, or rather the adjacency as it's called. So we've got no ISIS adjacencies. We do have an IP address. Let's see. Oh, we've got no, so it looks like there's an issue between router D and router C. So let's take a look at 000 on router C and make sure they're in the same networks. So we've, so yep, we can see it's a /30, so it's going to be every 4, 0, 4, 8, 12, 16, 20. Those are all the network addresses for a /30. But we can see this is .10, but this is .14. So not only is, so actually this is in, yeah. So this is a valid, because it would be .12 would be the third subnet. So you can see this belongs to, if it's 0 through 3 is the first, 4 through 7 is the second, 8 through 11 is the third, 12 through 15 is the fourth. So we can see this belongs in the fourth subnet of /30s. It's the second it's the second host address in that, the network address being .12 and the broadcast address being 13. So it belongs to the fourth subnet. But we can see here, this belongs to the third subnet. So they're in different subnets. They have to be in the same subnets if they're going to be connecting to each other. So let's verify the documentation. So we can see here, C is going to get .10, .13, and .25. It looks like, okay, so it looks like I just might have not been aware of what the port mapping is going to be versus their topology versus the one I'm using. So let's see if, oops, I'd like that to come back. Thank you. Okay, so here it's a lot more clear if I just use this, what needs to happen. So we can see this is actually going to get .13. Okay, so it's going to get .13. Then the other one's already got .14, I'm hoping. I will need to change the other, yep, I will need to change the other links. So let's do a do show int descriptions and check the link to router B. So, oh, yep, see it's got .13. It's going to need to have .10. All right, and now this is going to need .25 on 9. But 9 is good to go. So let's go back on D and take a look at the ARP on the interface, and it probably won't have it unless it resolves, but I can try pinging across the wire. Oh, and it looks like there's still some kind of issue. Let's take a look at 000 again. So yeah, everything seems to be okay. It looks like it's just timing out. Maybe let's see if I can ping my own address. Oh, okay, I'm in the wrong. Okay. Oh, I think I never committed my changes. So yeah, I never actually changed it. All right, so now let's take a look at, so now we've got an ARP. So there's a gratuitous ARP for changing that, which created an ARP entry. So everything is good to go. We'll probably have a ISIS neighbor now as well, or ISIS adjacency. Perfect. So yep, state up. Everything is good to go in that regard. Now let's check the routing table as is suggested in the guide to make sure that we're functional. So yep, there they all are. So we got 4, 8, 2, 4. Now we've got the highlighted routes with a metric of 73. So that's pretty clearly the metric of 64 plus an extra 13 for something. I'm not sure what it's for, but it gives us some meaning down there. Then we've got, yep, .1, .2, and .3, so everything looks perfect. So what is the meaning of that metric 73? As expected, the 10.2.0.0/16 and 10.3.0.0/16 routes in device D's routing table are in device D's routing table as ISIS external routes with a metric of 73. If device C had not added 63 to the route, to the metric, device D would have a metric of 10 for those routes. Okay, so I misspoke when I said 64. 63, that makes a lot more sense. The default metric is going to be 10. So the LSP, advertising LSPs. What is even an LSP? I thought an LSP was a label switch path, but we're not doing any, we're not doing any MPLS, so I don't know why it's saying that this is related, because we're not doing MPLS, so I don't understand how LSPs are related, because it's saying that this is, no, it's not saying it's related, it's saying this is another thing you can look at, but it's not related to this, because this is not about MPLS, but this would be a label switch path is about MPLS. All right, so let's kind of combine the Wireshark video into one. Normally I do them in separate videos, but let's start by watching that metric change from 73 back down to 10, because that extra metric of 63 will be no longer added. Oops, and we've got the good old classic GNS error, so I can just exit GNS and then open it back up. All right, so now hopefully it will play nicer. All right, so now let's take the metric out. So many updates for Wireshark. Okay, so now we're going to have everything be the same, but we're not going to change that metric. So I'm going to do commit and quit. We're going to see the metric change for these routes. So now they're at 20. So let's stop the capture and let's see what happened to make that go to 20. Okay, so here's the good old-fashioned ISIS-CSNP messages. So there's also PSNP for partial messages, but we're going to be interested in these. And the other thing you can notice, which is kind of cool, is we don't have any IP addresses here. This is ISIS traffic. There's no, we don't even have a regular message that we had before. We don't even have the same headers that we had before, IP headers, because it's not IP traffic. So we don't even have IP headers. We don't even have an Ethernet header. It's just frame 3. This is not Ethernet traffic. This is ISIS traffic. Well, here's an Ethernet header actually. Yeah, so it is Ethernet traffic. Sorry, I misspoke about that. But it's definitely not IP traffic. There's no IP addresses. It's all done by that NET, network entity title, which I think we'll see pop up. But we can see the source and destination are just MAC address, are not IP addresses. The source is looks like it's a MAC address. But let's see if we can find, just to kind of keep it easier, and then maybe go back. And the other thing to notice about ISIS is it's a link state protocol, kind of like OSPF. So you get you get a map of the area. So this is, again, as I'm saying, this is not the ISIS video. I'm just kind of getting a head start when I get there. This is the BGP video, but if they're going to have ISIS be a part of it, I might as well dive into it because it's going to be a big section later on. So here's the network entity title section. Yeah, this is really interesting. I've actually never been able to look at this in Wireshark. Yeah, it's completely different. There's no IP addresses at all. It's just ISIS addresses, network entity titles, and MAC addresses. But this looks, I'm willing to bet that the change is going to be in a PSNP message. It might be in the special ESIS. I'm not sure what that is. One thing that's nice about Wireshark is you can, I believe there's a help menu, but unfortunately all of the documentation is just community written, so it's not always reliable. So if I show packet in new window, can I get help? No, I can't. All right, so, as I said before, let's just try to keep it easy and see if we can sniff out that change in metric. So here's an ISIS LSP. So clearly it's not necessarily always going to be MPLS. I know LSP stands for Label Switch Wire Order in MPLS, but it looks like it's something that's specific to ISIS as well. Let's just go ahead and read this because it's something to see also. So let's take a look at it. You can configure your IGP to treat an LSP, whatever that is. It doesn't define it or list out or tell you what it is, as a link. Now an LSP, what section does this even belong to? It doesn't tell you any of that. Okay, well, let's just read it and then hopefully it'll be useful later. IGP shortcuts allow only the ingress router of an LSP to use the LSP in its SPF computation. So SPF, we know that's going to be shortest path first. So yeah, this is not label switch paths. This is LSPs, which are unique to ISIS. Before reading further, let's read an overview on ISIS. And, you know, as I mentioned before, this is not the ISIS section. That's going to be later, but this is something that, let's see here. So LSP is not there, but this is the whole ISIS user guide. So let's span the whole thing and then go LSP. And hopefully we can get a simple explanation of what an LSP is. It looks like they don't have anything particular to LSPs, but they do have explanations of particular commands with LSP in them. So maybe there'll be some better explanation in there. So understanding ISIS configuration, maybe LSP will be in there. Nope, no LSP. Unfortunately, we might need to just do a straight configure. Here we go. Here's something. So LSP interval. But we might need to go right to the RFC or just look for some free educational material online. Yeah, that's what I thought. RSVP LSPs. I thought it was a label switch router. So ignore the metrics for RSVP label switch paths, LSPs, in ISIS traffic engineering shortcut calculations, or when you configure LDP over RSVP LSPs. If you are using RSVP for traffic engineering, you can run LDP simultaneously to eliminate the distribution of external routes in the core. The LSPs established by LDP are tunneled through the LSPs established by RSVP. LDP effectively treats the traffic engineered LSPs as single hops. Ignoring the metric of RSVP LSPs avoids mutual dependency between ISIS and RSVP, eliminating the time period when the RSVP metric used for tunneling traffic is not up to date. So that seems to be, yeah, so configure label switch paths, LSPs, to be retained as cost equal paths for load balancing when a better path metric is found during ISIS internal routing table calculation. When a route with an improved metric is added to the ISIS internal routing table, ISIS flushes all next hop information, including LSP next hop information for a route. This is undesirable because certain equal cost path ECMP combinations can be lost during route calculation. Did we see ECMP on here? No, it was like ESIS or something. Yeah. To override this default ISIS behavior, include the LSP equal cost statement for load balancing so that the equal cost path information is retained in the routing table. Yeah, so it's interesting because this is just like further affirming that LSP is, here we go. This is probably it, because we're choosing an LSP interval for ISIS. So configure the link state. Perfect. Yeah, so LSP, of course, applies to MPLS, and it's the label switch path. But yes, it has its own meaning in ISIS, and it stands for link state protocol link state PDU. That's also another meaning for the acronym LSP. So the International Organizational Standards, or as they call themselves, the ISO, not the iOS, believe it or not, is advocating, or believe it or not, a lot of the times the language used in networking is ambiguous, is doublespeak, is really kind of not ideal. So I think this is a good case of that, where link state BPDUs, abbreviating that as LSP, is just not cool. But we finally found our answer. Thankfully, I didn't even know if we would even find that. And everything I'd read so far was kind of affirming my belief that LSPs are for MPLS. But nope, that's not true. Yes, LSPs can be label switch paths for MPLS, but an LSP can also be a link state BPDU, and that's a concept specific to ISIS. So when you hear the term LSP in advanced networking for service providers, there's two different things it could mean. So you're going to have to ask for clarification or just rely on the context. But even relying on the context, as we saw, there are special configurations you apply to ISIS depending on how you want to handle MPLS LSPs. So you really, even in the context, can't really tell if you're talking about those link state protocol data units or if you're talking about something dealing with MPLS. It's just LSP is not a acronym that is unambiguous. It's a very ambiguous acronym. All right, so description. Configure the link state PDU interval time. By default, the routing device sends one link state PDU packet out an interface every 100 milliseconds. To disable the transmission of all link state PDUs, set the interval to 0. Link state PDU throttling by use of the LSP link state PDU dash interval statement controls the flooding pace to neighboring routing devices in order to not overload them. Also, consider that control traffic, such as link state PDUs and related packets, might delay user traffic information packets, because control traffic always has precedence in terms of scheduling on the routing device interface cards. Unfortunately, the control traffic transmission rate is not decreased on low bandwidth interfaces such as DS-0 or fractional T1 and E1 interface. Line control traffic stays the same. On a low bandwidth circuit that is transmitting 30 full MTU size packets, there is not much bandwidth left over for other types of packets. So yeah, you know, as I was saying before, your control traffic can eat up a lot, and especially if you've got really low bandwidth connections, which I mean you might need like military purposes, ATMs. You know, there are lots of things that don't require a lot of bandwidth. So you're going to need to adjust your LSP video intervals, and maybe even just turn off your LSP hellos because it's just too much extra chatter on the line. And if you've got a connection, you can just assume it's up there without any issue. So let's actually do that. So let's start the capture again, and let's set the LSP link state PDU interval to 0 and see how that affects the chatter that we get in Wireshark. So edit protocols, ISIS, set LSP interval. Oops. So we've got LSP lifetime. I bet you I'm going to need to do it on the actual interface. So set interface GE000.0, set family ISO L, set L, edit family ISO, set, so we got MTU, we've got address, set L, that's interesting. So top edit protocols ISIS, set, so we've got LSP lifetime. I don't see LSP interval though. Let's see where that gets applied. So protocols, ISIS, interface. Okay, so it's a specific setting. So if I do show pipe display set relative, you can see I've got to go into the interface. So edit interface there. Now set LSP interval. We're going to turn them off and see how that affects the capture. So right now we've got 6 packets captured. I have a feeling that the capture has stopped, so I'm going to start it again before committing this. Oops. Value 0. Oh, you can't set it to 0. Well, let's set it really, really long because I think by default it's set to 100. So setting it to 1000 is going to clear up that chatter on the link. And of course, it's a trade-off too. If you've got the extra bandwidth, the more chatter you've got at that link, the faster it's going to detect issues and fail over. Otherwise, it could be, so let's see here, how many, so that's in milliseconds, so you don't want to wait that long for it to fail over. All right, so so milliseconds, so what is that, 10 seconds? 100 milliseconds is 1 second. Is that what milli means? I thought 1,000 milliseconds would be 1 second. This is embarrassing. Yeah, okay. I just need to go with what I know to be true. Okay, so now it's going to go down to every second. Let's try bumping it up. Well, let's just roll that back and kind of move on. I mean, as I said, this is not the ISIS section, so I don't want to put too much time and effort into ISIS and just never make it through all the topics on this exam. I've got a lot to get through, so I want to keep going through. What I will do, though, is finish the reading materials just to have that kind of primed for when I do get to ISIS, and then I will end the video, and the next video will be this next example. So the next command to learn about that is specific to link state PDUs, which is not a label switch path for MPLS. It's the ISIS specific acronym that is LSP. This is going to be, the description is specify how long a link state PDU originating from the routing device should persist in the network. The routing device sends link state PDUs often enough so that the link state PDU lifetime never expires. Because link state PDUs have a maximum lifetime, they need to be refreshed. Refreshing means that a routing device needs to re-originate its link state PDUs periodically. The re-origination interval must be less than the link state PDU's lifetime. For example, if the link state PDU is valid for 1200 seconds, the routing device needs to refresh the link state PDU protocol data unit in less than 1200 seconds to avoid the removal of the link state PDU from the link state database by other routing devices. The recommended maximum link state PDU origination interval is the lifetime minus 300 seconds. So in a default environment, this would be 900 seconds. In Junos OS, the refresh interval is derived from the lifetime and is equal to the lifetime minus 317 seconds. You can change the lifetime to a higher value to reduce the number of refreshes in the network. You would rarely want to increase the number of refreshes. Often these periodic link state PDU refreshes are referred to as refresh noise, and network administrators want to reduce this noise as much as possible. The show ISIS overview command displays the link state PDU lifetime. So let's see so by default, link state PDUs are maintained in the network databases for 20 minutes, 1200 seconds before being considered invalid. This length of time, called the LSP lifetime, is normally sufficient to guarantee that link state PDUs never expire. And those are LSPs, link state PDUs. So let's do that command, show, and this is kind of a glimpse into the future and why I don't want to spend too much time on BGP, because we can see just how gigantic of a topic ISIS is going to be. So if I spend all my time on BGP, I go into the test and it's all about ISIS. That's going to be a problem. All right, so commands. So let's see where the lifetime shows up in this command. Here it is. So it's set to the default. Okay, so I've got one more thing to read, and then that will be the end of the video. So advertising LSPs and LSPs, when we're talking about ISIS, which this is talking about, we're not talking about any MPLS, stands for link state PDUs. So advertising link state PDUs into IGPs, interior gateway protocols. You can configure your IGP, interior gateway protocol, to treat an LSP, link state PDU, as a link. IGP shortcuts allow only the ingress router of an LSP, link state BPD. Oh no, this is definitely talking about MPLS. I mean, I'll just read it because MPLS is going to be on there too. But yeah, this is definitely not standing for link state PDU, because an ingress router right there. That's how I know it's about MPLS and not about ISIS. IGP shortcuts allow only the ingress router of an LSP to use the LSP in its SPF computation. I mean, that's where it's confusing me though. LSP, SPF. Do they do SPF computations? I didn't know that. Oh, it does. It does a constrained shortest path first computation for LSP. So this is what they're talking about. Yeah, that might be worth reading about. But you know, as I said, this is now we're getting into MPLS, which isn't even. If I pull up the curricula again, you know, it's either its own topic or it's. Well, we can see, you know, it's probably going to be under yeah, so it's its own topic. And so we can see LSP selection. Well, where would it be under? Probably something like, oh, it looks like it's not even on here at all. So yeah, there's really no sense reading about it. And there's really no sense reading about this too, because it's for MPLS. So here we go. So because an LSP is announced as a unidirectional link, you might need to configure a reverse LSP, one that starts at the egress router and ends at the ingress router, so that the SPF bidirectionality check succeeds. As a step in the SPF computation, ISIS considers a link from router E to router D. Before ISIS uses any link, it verifies that there is a link from router D to router E. Otherwise, the SPF computation will not use an announced LSP. And this is label switch path, not link state PDU, I think. I mean, I'm not clear about that. I know LSP is an acronym that's used in ISIS. So it's very unclear. Understanding ISIS pseudonode LSP. Link state packet. Oh, so I guess it's not just link state PDU. Oh, packet they're using instead of PDU. I think they mean the same thing. Yeah, I guess the so an IS generates link state PDUs. Yep, to advertise its neighbors and destination that are directly connected. But I don't see anything about like an ingress router, because an ingress router, that sounds like MPLS terminology. So I really kind of don't understand how it's important to see also this if LSPs stands for something relating to MPLS. Like, I understand why you would see it also because we're learning about ISIS here, but yeah. Okay, so with that, I think I'm going to save the deep dive into ISIS for when I move on to IGPs, and then of course I'll save the deep dive into MPLS when I learn about MPLS. For now, I'm just focusing on BGP, which is peering communities. So this Wireshark capture, really, we're just looking at ISIS. We're not looking at really peering communities with it. So I'd like to do a capture where we can see some BGP traffic, because that's the topic of this. So I think I'm just going to find that. And then maybe once I've got some BGP traffic, just take a look at that. We should just see some hellos and maybe get an update going as well. Oh, one thing though is the, yeah, I don't think there's even going to be a BGP neighbor ship. Yeah, BGP is not even running because our neighborship is just between C, router C, and so here's BGP on the link between router B and router C, and they're not hellos, they're keep alives. So keep alive messages we're going to see. Let me take a look at where those BGP neighbors are going to be between. So we're going to have eBGP here and iBGP there. So there's just a BGP connection between B and C. There's nothing on A, and there's nothing on D. But what we are going to do is take our BGP routes and we're going to redistribute them into ISIS. So you can see very clearly on router D, show routes, we do have the routes on router C that were received from router E, this dot 2 and dot 3, over eBGP, but they're received as ISIS routes. Oh, and it looks like that metric never got back in there. So let me put that back in there. Configure private, rollback 1, show pipe compare, commit, and quit. So hopefully that metric gets back on there. Yep, so now it's 73 again. That is super fast. And their ISIS routes. Let's take a look at one of these routes on router C so we can see, sure enough, it is a BGP route. So yep, it's a BGP route received through that eBGP connection. Let's take a look at one of these routes on all of these just for curiosity's sake. And the other thing we can do is get rid of it from being advertised from E, and then we'll see an update message in our Wireshark capture. So we're going to delete this static route. Now roll back 1. And we'll just add it back because we'll get 2 updates. Yep, so here's our update messages for deleting. So we've got withdrawn routes. There we go, no more. Looks like we've got 2 of them, which is, okay, yes. So it's sending it to each router. And then we added it back in. So not only do we have, oh, that's the keep alive. Yep, so no withdrawn routes, but now we've got the network layer reachability information, but we've also got path attributes for it, including the community. So there we go. That has to do with peering communities. We can see that extra path attribute has been added there. So yeah, I think that's good enough to end on. Thanks for watching, and I'll see you in the next exercise.